So this is the whole flowchart of the wheat milling process, which is divided into cleaning process and the milling process. Welcome to the lecture series of Foodkida to understand the topics of food science and technology. In this video, I am going to simplify wheat milling process in detail, the process that turns whole grain into flour. So if you are new to the channel, make sure you have subscribed to the channel and this bell icon as well, so you will get the notification for the upcoming videos. Today, I'm going to talk about the wheat milling procedure. So let us begin. This is the lesson outline in which I will go through the general introduction of wheat, its structure and composition, and then how many different varieties of wheat are there, and finally the milling procedure that helps you to know how wheat harvested from field gets converted into flour, which we consume daily in the form of chapati and other products. And finally, the last topic, aging of flour. Let us begin with the general introduction of wheat. Wheat is the second most important crop in the world after rice. It is consumed in very large quantity by many people as a staple food, which provides energy as it contains carbohydrates. Its scientific name is Triticum aestivum and it belongs to the Gramineae family, basically a grass family. Most consumed form of wheat is wheat flour. Wheat is first being milled into flour and consumed in the form of various food products such as chapati, bread and many more. Along with the flour, certain products such as wheat flakes, puffed wheat and various breakfast cereals are also produced by small quantities of wheat. There are two primitive wild variety of wheat. First one is Triticum dicoccum, which is commonly known as amber wheat, and second one is Triticum monococcum, which is commonly known as incorn wheat. There are 25 species of wheat in the world, and among them only three varieties are grown in India. These three main varieties are Triticum aestivum, Triticum durum, and Triticum compactum. Triticum aestivum, commonly known as bread wheat or common wheat, which is mainly used in the production of bread, biscuit, cookies, cakes, chapati, and around 95% of production is done in India. Now, second one is Triticum durum. It is the durum wheat or macaroni wheat consists of more protein than other varieties and about 4% of production is done in India. Thus, it is used in the preparation of pasta products. Now, third one is Triticum compactum or club wheat. These the two varieties Triticum dicoccum and Triticum monococcum, collectively known as Triticum compactum. And among these two, Triticum dicoccum production is mainly occurs in India, which is mainly used in the preparation of semolina or suji, and its production is around 1% in India. If we talk about the history of wheat production in India, the production and productivity of wheat were quite low when India became independent in 1947, and the production was not sufficient to feed the Indian population. So several policies and action were taken by the government of India. Along with this, various scientists took some actions such as Norman Borlaug, MS Swaminathan and VP Pan. These three all are the agricultural scientists who developed some high yielding wheat varieties. Structure of wheat. If we talk about the structure of wheat, the overall structure of wheat is basically simple. Wheat grains are ovoid in shape, rounded in both ends. The seed is called kernel and it consists of three key edible parts: bran, endosperm and germ, which is protected by an inedible husk that protects the kernel from sunlight, pests, water and diseases. And in some wheat kernels, tip of each kernel is usually covered by stiff hair called brush. So overall, the physical structure of wheat consists of bran, endosperm and germ, and each part is further divided into various layers, tissues and regions. Bran. Bran is the hard brownish multi-layered outer protective of the grain. It surrounds germ and endosperm, protecting the grain from weather, insects, mold and bacteria, and it's about 15% of the kernel weight. Bran is the highly nutritious and excellent source of insoluble fiber. The bran consists of larger quantities of B complex vitamins and dietary fibers and a small amount of proteins, around 27% of protein and trace elements. About 90% of bran is used as livestock feed, while only 10% is used in the food industry as food fiber source in baking, fried foods, and breakfast cereals. That's why it is a major byproduct from flour milling. It is milled with the rest of the wheat kernel components for whole wheat flour and can also be bought separately. Also, bran has sweetness, nutty flavor, which is used to add texture and taste to bread. Therefore, bran helps to give sweetness and nutty flavor to the food products, but it depends on the production, what exactly you want to produce, and bran is indigestible. Now, endosperm. Endosperm is the biggest part of the kernel, and about 82.5% of the kernel is endosperm and source of white flour. Its function is to supply food for the embryonic plant during germination. Endosperm is the floury portion of the wheat kernel, and it consists the greatest share of proteins, carbohydrates, and iron, as well as the major vitamin B complexes such as riboflavin, niacin, and thiamine. It is also a source of soluble fiber. Now, the germ. Germ is the embryo or the sprouting section of the seed, usually separated from flour in milling because fat content limits the shelf life of the product. And it is about 2.5% of the kernel weight. Most of the wheat kernel fat and vitamin E content is found in the germ. The germ contains minimal quantity of high quality of protein and greater share of B complex vitamins and trace elements. Wheat germ can be purchased separately and is included in the whole wheat flour, although it is also used in the preparation of health foods such as fortified bread or whole wheat flour. Remember that bran and germ both are removed during milling. Composition of wheat. Different varieties of wheat has different composition, but roughly it contains around 10 to 14% of moisture, 69 to 75% of carbohydrate, 8 to 15% of protein, and around 2% of fat. Starch is the main carbohydrate, mainly present in the endosperm section of wheat, and also some soluble sugars and cellulose present in the bran and germ portion. There are two categories of protein. First one is non-gluten and gluten proteins. Non-gluten protein are albumin, which is water soluble, and globulin, which is salt soluble. Gluten proteins are gliadin and glutenin. Gliadin is soluble in 70% ethanol and glutenin is soluble in dilute alkali or acid. So when water is added to the flour and kneaded, dough is formed, and the protein, gliadin and glutenin present in the wheat combine together and form gluten, which is responsible for the extensibility and the elasticity of the dough, which provide strength to the dough. So the main protein, if ever asked that what is name the protein present in the wheat, then you have to always answer gluten is the protein which is present in wheat. Before going to the milling process, let us know what are the different varieties of wheat. Wheat is classified on the basis of type, color, and hardness. On the basis of hardness, wheat is classified into hard wheat and soft wheat. Hard wheat contains more protein and it is used in the manufacturing of bread, whereas soft wheat consists lower amount of protein, which is used in the production of biscuit, pastries, and cakes. And also it is easier to mill than hard wheat. And on the basis of color, wheat is of two types, red wheat and white wheat. The most clear difference between these two classes of wheat is the color of the outer coating of the kernel, that is bran, not the processed wheat. Red wheat has darker bran while white wheat has lighter colored bran. Red wheat typically contains more protein. It means it has a stronger presence of gluten compared to the white wheat. It is also classified into hard and soft red wheat and hard and soft white wheat. So basically these two varieties belong to the same wheat species, but they are classified separately on the basis of their color and protein content. And now on the basis of type, wheat is classified into three different varieties: Triticum aestivum, Triticum durum, and Triticum diacocum. Triticum aestivum is the most commonly used variety of wheat. If we look at the consumption in India, around 95% we are consuming Triticum aestivum. It is higher amount of protein content, and due to this it is also known as hard wheat, and thus it is used in the production of bread making, as it requires more desirable structure which can be fulfilled by the more protein content variety. Now the Triticum durum or durum wheat, which is mainly used in the production of semolina and macaroni products. It also contains high amount of protein, so it is also a type of hard wheat. So these two varieties are the type of hard wheat. Now the Triticum diacocum, also known as soft wheat, as it contains lower amount of protein. It is used in the production of such products where typical texture and strength is not required, such as biscuits, cakes and pastries. So this is all about the wheat classification. Now next, before going to the wheat milling procedure, first we will learn what is milling. Milling is a series of operations in which cereal grains are dehulled, dehusked, splitted or grounded into smaller pieces of flour to convert them into an edible form. So basically in milling, cereal grains are dehulled or debran to remove bran layer, dehusked in order to remove husk. For example, in case of brown rice production, splitted in case of pulses, or grounded in order to produce flour to convert them into an edible form. So basically it is a kind of size reduction process and separation process, and the ultimate goal is to produce edible food product. For example, wheat and paddy cannot be consumed as such, so they are first converted into an edible form and consumed by the people. So the main aim of milling is to convert cereal grain into an edible form. Broadly, milling can be of two types: grain milling and flour milling. In grain milling, the final product is grain itself. At the end, we are receiving the grain. For example, rice milling. White rice is produced from brown rice. So here at the end, we are receiving the grain, that is white rice. And in flour milling, that final product is flour. And here the grain undergoes the set of milling operations. And at the end, flour is obtained. Example, production of wheat flour from whole wheat grain. So the main objective of milling is to grind clean cereals and to obtain maximum amount of white flour from endosperm when we are producing the refined flour. So once when we are producing refined flour, we want to get maximum amount of flour from endosperm, and we do not want bran and germ get mixed into it. And third, to completely separate the bran and germ from the endosperm. Now we can say that what is wheat milling. So wheat milling is a process of grinding wheat for human consumption products such as flour, semolina and many more. There are two different methods of wheat milling: traditional method of milling and modern milling method. Before getting into the detailed procedure of milling methods, let us first learn what is the difference between whole wheat flour and refined wheat flour. Whole wheat flour, which is obtained from whole wheat grain. As the name suggests, it contains whole portion of wheat, means it will contain bran filled with fiber, endosperm with starchy carbohydrate, germ with packet of nutrients. So whole wheat is completely milled in order to produce whole wheat flour. But when we are talking about the refined wheat flour, bran and germ both are removed during milling and concerned with the starchy endosperm only. Comparatively, when we talk about the whole wheat flour and refined wheat flour nutritional value, bran and germ is absent in refined flour, so the net nutritional value will be lower than the whole wheat flour because it consists endosperm only. So refined flour must be lower in nutritional value when it is compared to the whole wheat flour. Generally, refined flour is used for the production of bakery products, whereas when we go for the consumption of wheat as chapati, we will go with the whole wheat flour. Now, wheat milling can either be done by the traditional method of milling or by the modern milling method, that is roller milling. So now first one is traditional method of milling. As the name suggests, traditional method is the method which we are using since traditional times. And in India, traditional method of milling wheat is stone grinding, chakki, to obtain whole meal flour, atta. The flour obtained contain bran, germ, and endosperm, all the three key edible parts of wheat. As we can see in the diagram, two circular thick stones made up of rough material lying on top of the other are used to crush the wheat, and this rough surface helps to crush the wheat by providing the friction when it gets rotated, and finally it is completely milled into flour. So ultimately wheat will be converted into flour with 90 to 95% extraction rate, and remaining are the broken or the left kernels. Flour obtained consists of all the nutrient part of the wheat because it includes bran, endosperm, and as well as germ, and along with this indigestible part of the wheat simultaneously get eliminated. Now, modern method of milling, that is roller milling. In this method, prior to milling procedure, wheat kernels are cleaned so that various types of impurities, foreign materials, and damaged materials can be removed. So the objective of cleaning is to get high efficiency while milling, and if some impurities are present, it will interfere the equipment and thus decreases the efficiency rate. So the first objective of cleaning is to get high efficiency while milling, to remove non-grain part and to remove grain which are not fit for milling and which might affect the final quality of flour that must be removed. There are three main steps in flour milling. First one is cleaning, second one is preparation, that is the preparing the wheat for grinding, and the last step is grinding the wheat. So the first step is cleaning, and there are number of equipments which are used in the milling process. First one is magnetic separator. As the name suggests, it consists of magnets, and with the help of these magnets any metal impurities can easily removed. So the main function of magnetic separator is to remove the iron or steel particles during harvesting. Second one is vibrating screen. As the name suggests, it consists of screen which are vibrating, which helps to remove the bit of straws, other coarse materials, and other foreign materials like seeds. So the main objective of vibrating screen is to remove the material other than the grain which will be present along with the wheat, such as seeds, straw, or any foreign materials come from the field along with the wheat grain. Next, aspirator. Here air is utilized for the separation, and while cleaning air is used to carry the lighter impurities such as dust. So it is used to remove all the lighter impurities with the flow of air. Next one is disc separator. This machine has certain series of discs in it, and these discs are revolving on horizontal axis which catches the individual grain. So only the particular size of grain is catched by the disc, and all the larger and smaller size materials are rejected in this step. Next one is scorer. Scorer have beaters attached to the central shaft which throws the wheat against the wall of the container and break the hair of the kernel. So with the help of a scorer, hair-like structure called brush present in the wheat are removed by the scorer. Next, washer stoner. Here, water is being used to remove stone. In this step, high-speed rotors spin the wheat in water, and with the help of centrifugal force, stone will get dropped to the bottom and lighter materials will float on the top, leaving the clean wheat. So the lighter material will start to float and heavier material will get settled down, and as a result clean wheat will be left. Now the second step is preparing the wheat for grinding. Basically it is a tampering or conditioning step, or also known as hydrothermal treatment. The meaning of conditioning is the addition of moisture to the wheat. The main aim is to increase the moisture content to 15 to 19%, and final moisture content vary from different types different types of wheat varieties, and moisture is added either at room temperature or at elevated temperature, but not over 47 degrees Celsius, to retain the gluten quality which affects baking quality of wheat flour. Moisture content of wheat rises from 1 to 2% and increases to 16 to 19% in hard wheat varieties and 15 to 17% in soft wheat varieties. In modern systems, the conditioning is done in three stages: preheating section, moistening section and cooling section. In preheating section, grain is heated in just 20 to 30 seconds to 40 degrees Celsius to 50 degrees Celsius, but not more than 50 degrees Celsius. The rapid heating weakens the bond between various parts and facilitates their separation. And after this section, wheat is moistened and cooled down in cooling section. Conditioning can also be accomplished by direct steaming. Now, tempering. Now, after adding the moisture, we have to give some resting time to wheat so that the complete moisture can be absorbed and all the wheat get the desired moisture content. So, holding of wheat is done for 18 to 72 hours in tempering bins to allow water to completely enter into the endosperm. Now the question is why it is done and why there is a need to increase the moisture level of the wheat. So the first reason is that it will help to separate the bran from endosperm easily and to provide controlled amount of moisture and temperature throughout the milling. Now, conditioning results in toughening of high cellulose containing parts, that is germ and bran, and soften the endosperm, which facilitates size reduction. So just entering into the grinding step, wheat is passed to the antolator, and this equipment consists of disc and small pins which revolves at high speed and through the grains and crack the unsound or undesirable kernel which may enter to the grinding step that are rejected. So in this step, finally, if any undesirable kernel or any other material left along with the wheat which are not fit for the grinding, they are removed by the antolator and enter into the grinding step. Now the third and the final step is grinding the wheat. First step in the grinding phase of wheat is breaking or crushing. The aim of breaking is to separate as much as bran and germ as possible. Means we are going to produce refined flour or white flour. Because of the production of white flour, we need endosperm only. So bran and germ get separated. And to produce maximum flour from endosperm after removing the bran and germ. So here we are removing the bran and germ and hence producing the maximum amount of flour, that is white flour, from the endosperm. The main aim is to separate the bran and germ as possible and to get maximum amount of flour from the resulting endosperm. For breaking or crushing the wheat, they are passing through the brake rollers and the surface of these rollers are rough, and here the main aim is to remove the bran layer to get endosperm. So there are number of rolls from which wheat is passed. It may be up to 4 to 5 times, and after passing through the brake roll, remaining part is passed through the reducing rolls, and in breaking step, brake rollers crack open the grains of wheat and begin to separate the interior of the wheat from the outer layer of bran. Now after cleaning and conditioning step, wheat grains are passed through the brake rollers and the surface of these rollers are corrugated and rough, and which helps to break or crush the wheat grains and remove the bran layer and endosperm will left behind. Now these brake rollers consist of multiple steps and around 4 to 5 steps are present. So after passing through the brake rollers, remaining part is passed through the reducing rolls, and these reducing rolls consist of smooth surfaces which ultimately produce the flour from endosperm, and it consists of about 12 to 14 reduction steps. And after passing from each roll step, they are passing through the sieves to get separate on the basis of size, and similarly after passing through each reducing rolls, they will be sieved up after each pass in order to separate depending upon the size. And when we talk about the wheat milling, we do not get only wheat flour. Along with this, certain products of different sizes we are also producing, and in the sieving steps, different sets of sieves are there through which different size of particles get separated. So at each step, after each pass, we will be getting wheat germ, wheat feed, bran and other materials on the basis of size at one side, and on the other side we will obtain flour, wheat flour in the second step, that is from the reduction step when it get passes through the reducing roll step. But after passing through the brake roll, small amount of flour also we are getting, and later it will get separated and get mixed with the flour which we are getting from the reduction roll. Breaking stage. In the breaking process, after tempering step, wheat is passed through the brake rollers. So first step is to pass them through the set of brake rollers, and these two brake rollers are horizontal rough surface corrugated rollers which rotates in opposite direction, and one roller rotates faster than the other one. And the brake milling is done in 4 to 5 stages, and first set of roller just crack the wheat grain initially, and once after cracking, bran is removed from the endosperm. So here the first roller break just only crack the grains, and thus the process is called as crushing. Once the bran is cracked, kernel is open, and the now milling process will be started. And after each set of break rollers, sieving is done. And from the series of last break rollers, flour, suji, rava or semolina products will be obtained. So finally, after the end of the 4 to 5 sets of break rollers, we are obtaining the suji, flour or semolina. And after each set of rollers, we are sieving the products on the basis of size. So once it is passed through the one set of roller, it is again passed through the second roll set of rollers, and again to the third one, and so on. And finally, after passing through the different roller steps up to 4 to 5 times, brake milling is done. And after each brake, mixture of free bran, free germ, free endosperm and endosperm still adhering to the bran is sifted and separated. Endosperm still adhering to the bran means from which bran is not completely separated, and this process will be continue. So the equipment which we are using for separating are plant sifter and purifier. Plant sifter removes larger pieces attaching with the endosperm at the top, and again it is used in the finer series particles to separate the bran and germ, and again to remove the endosperm. So the set of sieves which we are using are called plant sifter. Now the purifier. Purifier with the help of the hair helps to remove the any kind of finer particles before entering to the reduction roll. Second step is the reduction stage. So in this step, we will have the coarsely grounded endosperm called as semolina, which completely crushed into flour. Here, semolina is passed through the reduction rollers, which consist of smooth surfaces and rotate in the opposite direction with lesser speed as compared to the brake rollers, which finally milled into flour in 12 to 14 steps. And each time the flour is grounded and it passes through the sieves to separate into different flour of fineness. And after each reduction pass, sieving is done on the basis of size and pass it again to the next set of rollers till 12 to 14 set of rollers. And finally, by sifting, separating and regrinding the flour, several different grades of flour are produced at the same time. And if we talk about the extraction rate of modern milling, it is about 70%. So this is the whole flowchart of the wheat milling process, which is divided into cleaning process and the milling process. Firstly, grain is supplied to the factories or industries, and after that it undergoes quality control. Here wheat is tested for different parameters, and then cleaning is done using various equipment such as magnetic separator, which removes magnetic impurities, vibrating screens, which removes bit of straws, woods or coarse material, aspirator, which removes the dust and lighter impurities with the help of air, disc separator, and scorer, which removes the other minor impurities, and washer stoner, and with the help of water it removes the stones with high speed rotors. And after cleaning step, conditioning or tempering is done, which toughens the bran and softens the endosperm for easier separation for milling. And before passing to the grinding step, it passes through the entolator, which rejected any unsound kernel for grinding. And finally milling is done in order to get flour. So this is all about the grinding or the milling process, which we have already discussed in the previous slides. So this is a whole about the milling process of wheat. Now we will move to the next topic, aging of flour. Once the flour is obtained after milling, maturing treatment is given to the flour to improve the quality of flour products such as bleaching. So, what basically bleaching is, it is the removal of colorful compounds which whitens the flour. Now the question is why bleaching is done. As milled flour contains xanthophylls, which is responsible for the yellow color of flour and which is not desired for making products such as bread, bleaching is done. Now, when milled flour exposed to air, bleaching is naturally done by oxidation process. So when flour is stored around for 6 to 8 weeks, pigments automatically oxidize and get converted into colorless compound. But when it stores in bulk, this change is too slow. So for this, bleaching agents are added. And there are different types of bleaching agents such as nitrogen dioxide, benzoyl peroxide, potassium iodide, ascorbic acid, chlorine, and many more. And along with this, different types of biological compounds are added to the flour which act as a bleaching agents. So this is all about today's lecture. Let me know down in the comments if you have any doubt. If you found this useful, hit the like button and subscribe to the channel if you haven't. Also, join our WhatsApp group and follow us on our Instagram page for more information. Link is already given in the description box. Thank you once again, and goodbye.